Hi everybody, welcome to 8.5 partial fractions. So now we're going to integrate where we need to use another method, and that's with partial fractions. So we're going to talk about what our factors might look like or how we can set up those partial fractions. All right, so if we have our linear factors, so x, x minus 3, even x minus 3 squared or cubed, etc., okay? The way we would write our partial fractions is we would have a over x minus 3, or a over x minus 3 squared. Okay, so since they're all linear, we just have a constant in the numerator. If we have a quadratic factor in our denominator, we're going to set up ax plus b over that x squared plus 5, that quadratic factor. So let's dive right into our first example and remind ourselves about how to set up some partial fractions. All right, so the first thing is we've got this integral and we want to integrate 4x squared plus 13x minus 9 and x cubed plus 2x squared minus 3x. So let's try factoring, all right, and see where that gets us. So as you can kind of see my notes over here, factoring our denominator, we are going to be left with 3 linear factors, x, x plus 3, x minus 1. So I can rewrite this integral as this right here. So what that means is we need to set up partial fractions, okay? So I want to rewrite my numerator so that I can split it up with these 3 denominators. So let's take a look at our partial fraction work. Okay, so since they are all 3 linear factors, I can rewrite this numerator so it's a over x, our first factor, plus b over x plus 3, plus c over x minus 1. And we would keep going depending on how many factors we have in that denominator. Now, what we want to do is we want to multiply both sides, so everything gets multiplied by this denominator. When we multiply the left side, this guy goes away, and we're left with the numerator. Multiplying a over x times this quantity, the x's will cancel, and we're left with these 2 factors. Multiplying b over x plus 3 times this quantity, the x plus 3's cancel, leaving us with those 2 factors times b. And then accordingly, or similarly with c, all right, this factor, the x minus 1's will cancel, and we're left with x and x plus 3. So now we just want to go through and figure out or solve for what a, b, and c are. So if we let x equal 0, that's going to take away b and c, because 0 times b times this, it goes to 0, and same goes here. So we're just going to be left with being able to solve for a. So when we plug 0 in for x, this goes away, we're left with negative 9. 0 plus 3 is 3, and 0 minus 1 is negative 1, times 3, we get negative 3a, so we can solve for what a is. If we let x equal 1, this term is going to go away. Same with b, and we'll be able to solve for c. So again, plugging 1 into the left side, we get 8. Plugging 1 in over here, we get 1 times 4, so we get 4c, so c is 2. The last thing I look at, okay, well, I need x to equal negative 3 if this x plus 3 factor goes away. So that'll get our a term away and get our c term away so that we can solve for b. So plugging negative 3 into the left side, we get negative 12. Then negative 3 times negative 3 minus 1. So that's going to give us positive 12 times b, and we get b to be negative 1. All right? So now we can go back and rewrite our integral in terms of these partial fractions, plugging in for a, b, and c. So we get, it's really the integral of 3 over x minus 1 over x plus 3 plus 2 over x minus 1 dx. And now we can integrate this nicely. Hopefully you have no issues here using a simple u substitution for these last 2, and we get our final answer. Now this last one is just using those log properties, so moving that 3 to the power, since we're subtracting, that x plus 3 goes in the denominator there, and we should have a little parenthesis, and then adding again and moving that power, we get x minus 1 squared. So here's our final answer, and let's go on to the next one. Okay, so again, the first thing we want to do here is we want to factor that denominator. Okay, now I'm going to jump straight to it. When we factor, we're going to get 2x minus 1 and x squared plus 4. So here we have a linear factor, which is similar to what we did in the previous example, but here this x squared plus 4 is a quadratic factor. So that's the only thing that's going to change a little bit. So now let's kind of zoom in on this partial fraction work to see how we got what we got. Okay, and it certainly wouldn't hurt for you to try this on your own and come back and check to make sure that you got what you should get. Okay. So the way we would set it up, all right, I have a over my linear factor, but over my quadratic factor, this is where we have that bx plus c. Again, we're going to multiply everything through by these two factors. So then we're going to be left with a times x squared plus 4 plus bx plus c times 2x minus 1. Now, if we let x equal 1/2, that's going to take care of and eliminate these two over here because 2 times 1/2 minus 1 is 0. So we can solve for a this way. So again, plugging 1/2 into every x value, we get 1/4 minus 1/2 minus 21 equals a times 17 over 4. Now just multiplying every term by 4 here to kill the denominators, we're left with this here, and we can solve through to get a to be -5, so that works out nicely. But now we need to solve for b and for c. So I'm going to plug in my a equals -5 here, and I'll distribute that. So that's where we got -5x squared minus 20. Foiling these two, we get our 2bx squared minus bx plus 2cx minus c. And now I'm just going to kind of organize things. So my quadratic coefficients, I have a -5 and I have this positive 2b. So I'm just rearranging it. 2b minus 5x squared. And then my linear coefficients, we have a minus b and a plus 2c as the linear coefficients. So we're just rearranging 2c minus b times x. And then all of the constants. We have this -20 and this -c here. So now I'm just going to kind of focus and set things equal, right? So looking at the quadratic coefficient here, it's just 1. And the quadratic coefficient here just has my b value. So setting those equal, we can solve for b to be 3. And noticing my constant only has c, and my constant over here is -21, we can focus on those two pieces to solve for c, setting them equal, and we get c to be 1. So now we can go ahead and rewrite our integral in terms of those partial fractions. All right? So as we do that, one last thing is now I can break this guy up into two fractions as well by splitting up that numerator. So we really have now these three integrals. This middle one is just a straight u substitution where u is x squared plus 4, du is 2x dx. So that works out nicely. This one over here, that's going to be an inverse trig function when we integrate it, and turns out to be inverse tangent. So hopefully you can recognize that. So by splitting it up, we're able to get to where we need. Then finally, we can go ahead and integrate each of these. Hopefully we're comfortable with that at this stage, and we get our final answer. Moving on to the final example here, we're going to look at a repeated linear factor. Okay, so this is already in factored terms, or in factored form, the denominator. So as we get to our partial fraction work, I'm going to kind of just go through a little bit, and I want you to take care of the rest to see what A and B are. So with a repeated linear factor, we're going to split it up, okay? So we would write it as A over x plus 3, then plus B over x plus 3 squared. If I was raising this to the third or fourth or higher powers, I would keep on going, okay, accordingly, right? Raising the power each time. All right, so now what I want you to do is I want you to go through and solve for A and B. When you do, come back and check to see how you did. Okay, so hopefully you got what I did. So multiplying everything through by x plus 3 squared, we are ending up with a times x plus 3 plus b. Now kind of carrying this out and cleaning things up, all right? A is the coefficient of x, 3a plus b is our constant. So we can kind of zoom in. 8 has to equal a, and then 3 has to equal 3a plus b. Well, we know a is 8, so then we could solve for b to be negative 21. So hopefully you got that, all right? And now we can go back and finish this problem up, all right? So here we have the integral of 8 over x plus 3 dx plus the integral of negative 21 over x plus 3 squared dx. So here we can use that u substitution, all right, and kind of work through it. So this is really negative 21 times the integral of u to the negative 2. And integrating through, we get our final answer here. All right, don't forget those plus c's. If you have any questions, make sure you ask.